There. Okay, last class we left off at 4.1. Here we have 4.2, the least squares regression. All right, a least squares regression line is the line that minimizes the sum of the squared errors or residuals. Squared errors, the sum of the squared errors or the residuals. Those terms can be used interchangeably. Well, errors and residuals. The line that best explains the relationship of the data is also a characteristic of the least squares regression line. And so right there, I have a general drawing of what we mean by that. You know, you can have points. We talked about scatter plot, scatter diagram last class. And so the line that best sums up that relationship would be your least squares regression line.
Mr. Tucker, I have a question.
Yep.
Last semester how we for our midterm and then our final exam we did Proctor exams. Are we kind of doing that the same way this time as well?
So you say you want a midterm and a final and 4 tests? That's what you're asking
Hey,
for?
yeah, might as well. Hey, oh my God, I'm totally
But you
kidding.
remember
I know
though.
everybody else is like, oh
I
my
know,
God,
speak for yourself. Hold on.
No,
So
don't
don't
do me
forget
like that.
that class was set up a little different. Remember that class
Okay.
only had the midterm and the final.
Okay, thank God.
But
Because I was okay.
yeah, this class it's a little more flexibility with this class than the other
Okay.
class, and that was structured a little different. This class, you notice I have a test after ever so many
Yeah. That's
sections.
what I'm trying
So
to figure out. Like,
yeah,
okay.
so that we'll have a final. We won't have a midterm.
Oh, cool.
Yeah,
Okay, cool.
yeah.
All right, y'all. I'm quiet now. Bye.
you about to, you about to start a mutiny in a riot.
I know.
But
But
yeah.
honestly, I just really needed to know so I could be confident
Oh no, you're fine. It's
semester
not. It's
with
not
it. You
like
know
what
what I
you.
mean?
Yeah, it's not like what you know. Like you're like, oh, okay, since you asked for it. No,
Yeah, I know, right? No, I
you'd have been
know.
fine.
Okay, cool. Okay, bye.
Everybody done with that? Okay. So let's look at finding the regression line. So we have y hat. This symbolism, or not symbol, this symbol right here. Whenever you put that over your variable, that's you would say that variable hat. So that would be y hat. If you had that over x, it'd be x hat. So that's how we use that symbol. That also represents your predicted y, and we'll talk about what that means in a second. But that also represents your predicted y. The way we will find that is b1x plus b0. b1 is going to be r times s sub y over s sub x. We'll scroll down, let you know what that means in a second. And b0 will be y bar minus b1 x bar. Notice you have to find b1 first before you can find b0, because b1 is a part of the calculation of b0. Also take note that b1 is going to be your slope. That's what's sitting in front of x. And y-intercept is going to be b0 or b0. So give you a chance to write that before I scroll up. In my math lab, I believe we'll ask you, what's the slope and what's the y-intercept. So, you know. All right. We saw last class that R is our correlation coefficient. X bar is going to be the mean of the X values. S sub X will be the standard deviation of the X values. Y bar is the mean of the Y values. S sub y is the standard deviation of the y values. Remember last class we talked about your explanatory variable versus your response variable. So your explanatory variables are your x values, your response variable are your y values. That's where we're getting the x and y from. Scrolling up. And so right there in the purple lets us know what we will be using our regression line for. It's used to predict an observation based on previous observations. Should say predict an outcome. Let me do that. I like that better. Predict an outcome based on previous observations. So regression line is used to predict an outcome based on previous observations. Good. All right. Everybody finish copying. So when we get to this next example, you'll be asked to find a regression line. You could be asked to find a regression line one of two ways. They could give you the information like this. They could give you R, X bar, S sub X, Y bar, and S sub Y. Or they can just give you a set of data, raw data. And then that's when you would use your app, website, or calculator in order to find it. So we'll do both of them, an example of both. All right. So let's look at the first way. This first way is going to use the formulas and the relationships that we just finished discussing. Here we have find a regression line. R, our correlation coefficient, is going to be negative 0.946. X bar, 4. S sub X, 2.44949. Y bar is equal to 10. S sub Y is 5.612486. All right. So what we're going to do is use the relationships to figure out what our regression line would be. B1 is, like I said, just follow the formula. R times S sub Y over S sub X. So we plug in the values accordingly. R is negative 0.946, and then that 5.61 divided by that 2.44 number. Put that in your calculator, and we'll have B1 to be negative 2.1676. All right. Then we can find B0 or B naught. That's Y bar minus B1 times X bar. Plug your values in accordingly. 10 minus negative 2.1676 times 4. That's going to be 18.6704. So before we go any further, questions on how we found B1 and B0.
Do I have to use a specific app or something, or is my scientific calculator okay?
Oh no, for this, the scientific calculator is fine.
Okay.
Yeah, this is just regular calculation.
Yeah.
When we look at the next way to find your regression line, then we would go to like easycalculation.com or something like that. Yeah.
Okay.
Yep, but you can use a regular calculator on this. Once you found B1 and B0, all you're doing is plugging it in. This is the way it's set up. B1, you put that in front of X or attach it to X. That's negative 2.1676 X, and then that'll be plus 186704. My math lab, We'll set you up this way, wherein they'll have a box. You know, the one that's attached to X is where you will put in B1. And then the other one would be where you would put in B0. And then in this last box, I just wanted to emphasize that, you know, it doesn't matter which order you do it in, as long as your signs stay the same. And whatever, if B1 is attached to X, then it's fine. So notice negative 2.1676 is back here, but it's still negative 2.1676, you know, X. And the 18 is still positive, but that's in the front. So they're the same thing as long as the signs are the same. And what is connected to X is still connected to X. You still have the same equation. All right. Questions on this one?
So far, so good.
All right. Everybody good? Can I scroll all the way up?
Yeah.
Here goes the next one, okay? Give you guys a chance to write it. So the first part of this is we're going to find a regression line. Part B, we're going to predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. So this is when we're going to actually use the regression line in an application. And then C, determine the residual. Remember, that's our error. Determine the residual for the predicted value from the result. And C is the distance in the table above or below average among balls hit at 103 miles per hour. All right. Everybody good. Let me erase this. So we're going back to that club head speed for our explanatory variable and distance for our response variable. If I scroll up and somebody's still copying that last question, please let me know. Okay. And so, and I'll just notate in here that, you know, this is our explanatory or our X. This is our response variable or Y. Talked about that last class as well. But it's same values. If you copy this chart last class, it's the same chart. So this time they give us these data values or observations. So if you have it in this form, they give you the data in this form. This is when you go to, like I mentioned before, to easycalculation.com, go to some, you know, app, something of that nature that will help you to be able to calculate the regression line. All right, so is everybody done copying this before I switch screens?
Yeah, it's good.
All right, anybody else? All right, so let's go. Oh, there's so many windows up. Nope, that's not it.
Oh wait, could you go back 1 second? Oops.
Mm-hmm. Let me know when you're ready.
Thank you. I'm ready.
Cool, not a problem. So just like we talked about before. All right, so now I gotta find my screen again. Awesome, there we go. Got so many windows up, need to close them out. I would just do regression line, easy calculation. And the first one should be the regression line calculator. So, you know, we can add rows as you see fit and take them away. Now I have already done this one. Hopefully it's still there. Yep, there we go. So you type them in, and remember, don't forget to make sure you're careful if you do 257. If it's 257 and you put in 256, it will change your numbers. So you always got to make sure that you go back and check your values. Make sure everything is what it's supposed to be, because one digit off will change everything. And yep, so you just type in your values, hit enter, and see we have it. Notice it called it our slope, called it our y-intercept, and it even put it in the regression line form. So questions on that before we go back to our notes?
Thanks for like showing us how to use it.
Yeah, not a problem, not a problem. All right, so let's go back. And let me start moving a little slow here. Give me 1 second, closing out some of this stuff. All right, should be good to go. All right, so there go our line, our regression line. So once again, just showing you both ways that you could write the regression line. And once again, that's what we just pulled from the website. So I didn't do anything special as far as calculation is concerned. That's what we just pulled from the website. And so B says predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. Now that's what the regression line is used for. You have something that you want to, you have an observation that you would like to, or an outcome that you would like to see. What would your regression line predict would be based on what you've already observed. So you plug it into your regression line equation for X and do the calculation, and we get 270.3 yards. And once again, that's our prediction. So we're predicting that on average, when you hit a ball at 103 miles per hour, your distance, or the distance the ball will travel, will be 270.3 yards. All right, any problems with that? Going to C, determine the residual for the predicted value from the result in C. Is the distance in the table above or below average among balls hit at 103 miles per hour? So when we go to our table, notice we have an observation at 103 miles per hour. The distance the ball traveled was 274 yards. So the residual or error is going to be your observed y minus the predicted y. So you can't find the error if you don't actually have an observed outcome. So we have an observed y and your predicted y. If you're talking about notation, your observed y is just y. Your predicted y we talked about already is y hat. So that's just a notation that you may see, whether it be in my math lab or in the book. So we'll go ahead and do our subtraction. 274 was the chart value. 270.3 was the equation value that we just got from 103. And that's 3.7 yards. So make sure we're okay before we talk about what that means. So our residual would be 3.7 yards. All right. So what does that mean? The observation in the chart is above average balls hit at 103 miles per hour. And so it's above average because it is positive. Now, if it was negative, then you would say it's below the average balls hit at 103 miles per hour. All right. Questions on that? All right, I think that's okay. Yep, going to 4.3. So, questions on anything on 4.2 before we go into 4.3?
Can I see the equation that you used to get 270.3 again? Just real quick.
Right there at A, but we plugged it in at B.
Right. Okay, cool.
All right. All right, 4.3, coefficient of determination. So, coefficient of determination measures the proportion. I was like, oh, what did I write? Guess I should write that better. All right, so it measures the proportion of total variation in the response variable that is explained by the regression line. So it basically tells us how reliable the regression line is. All right. Here's the correlation coefficient squared. It is denoted by capital R squared. It is between 0 and 1 inclusive. If I scroll up too fast, of course, let me know. If your correlation, no, if determination, coefficient of determination, I had to get my words right. If your coefficient of determination is equal to 0, the regression line has no explanatory value. If it is equal to 1, then the regression line explains 100% of the variation in the response variable. All right, so make sure we're okay before we go to the example. All right, so let's determine and interpret the coefficient of determination for the club head speed versus the distance. So once again, we're going back to our club head speed and the distance the ball travels. So whenever you're trying to find the coefficient of determination, first thing you have to find, of course, is a correlation coefficient. That's your lowercase r. We've already found that. That's 0.939. Then we can find the coefficient of determination, and that's just squaring the correlation coefficient. So we took 0.939, squared it, they gave us 0.882. Or if you want to write it as a percentage, that's 88.2%. All right. So let's look at the interpretation of it. But any questions on how you find it? All you have to do is make sure you find a correlation coefficient. Once you find a correlation coefficient, you just square that. That will be the coefficient of determination. So now we're looking at what it means. So the first thing we recognize that 88.2% of the variation in the distance is explained by the regression line. Subtract that from 100, that means 11.8% of the variation is explained by other factors. So in other words, if the outcome doesn't go along with the regression line prediction, in other words, you know how we had the 103 miles per hour, we had that 270 was a prediction, but it was hit at 274. So that's right around the same type of number. But let's say you hit it at 103 miles per hour and it goes 350 or something crazy, I don't know. And so that wouldn't be in line with what normally happens. So they're saying there are other factors that are in play when you're talking about the accuracy of the regression line. So, you know, anything like human error could occur. I mean, you're outside, you're talking about wind resistance and stuff like that. Other factors could explain or could be the reason as to why an observation does not line up with what the regression line would predict. And so the third statement there is that the regression line has an 88.2% reliability. All right. Questions? Any questions?
Sure, once I get into the homework, I'll have some.
Mm-hmm. Yep. Probably should. Well, it should occur. Well, I won't say it should occur. You know, you might be nice with it and just be good. You know, it's possible.
Yeah, right. This
It
is
is
definitely
possible.
like harder than last semester. I was tripping last semester, but I'm
did so well, but like this, I'm like, yo, what? But it'll be fine.
Yeah, you just got to get settled. It'll be all right.
Yeah.
Just like last semester. You know, we started off like that last semester as well. You know, with that 154.
I guess what my question would be, like, remember how I said last semester, how is it, I mean, repetition, the same thing, right? You know what I mean? That would.
And this class is less about the calculation and more about the application.
Okay,
And,
that's what I was like, because I don't really, see the, yeah. Okay.
Right. That's why I say, yeah, just go to a website,
Right.
you know, calculator, whatever, and plug in. This class is more about the application, you know, so.
Process of it, okay.
All right, y'all, we gonna get this.
I'm like, oh my God, it's my last semester too, and I'm like, yo.
So
we good.
yeah, we're gonna be all right.
Yeah.
So don't forget, I gave you that assignment. Once some of you have turned it in, some of you haven't. So just make sure you get it to me as soon as possible. But now we have assignment 2. Now assignment 1 was only 4 problems. Assignment 2 was only 3 problems. I'm pretty sure you guys have had legitimate assignments in other classes that were way longer than 7 problems.
100%.
So just throwing that out there. Don't make it like a big thing where it's 4 problems in one assignment, 3 problems in this assignment. And don't forget they are all odd. So that means the answers are in the back. So really it's just about you challenging yourself to make sure you can get those answers that are in the back. And if you can't, that's when you need to ask me questions so we can make sure you're good moving forward. So next class, this is it for chapter 4. Chapter 4 was on 3 sections, and that's why you have 1 problem out of each section. Next class, I'll open the floor for questions. So take the time out, see if you have any questions, or see if you generated anything in my math lab. Any questions are generated. See if there's anything you want me to re-explain or redo or something like that, and we can talk about it on next class. And so yep. And so notice we're out of chapter 4. This is why I was telling you guys to make sure that
Yeah, you get
all
all
on
that
the stuff. Yeah, and don't.
Once you start drowning, you like can't breathe no more. You're like, I'm so lost right now. So yeah. Definitely.
So next class, I'm not looking to do anything new, but I will answer questions. But if nobody has any questions, I mean, you're not gonna just sit here and look at each other. I guess we'll just call it a day,
I know.
So yeah. So next class will be your time to ask whatever questions you want to ask, and then we'll go from there.
Okay, awesome. Well, thank you so much. You guys have a good day.
Thank you. Have a good day.
You guys do the same.
Good afternoon, sir.
All right, thank you. You
And
do the
everyone
same.
else.
Good day. Bye.
Take care.